Welcome to Ask and Learn.
We were asked to solve a word problem using recurrence relations. We're told that there are 2 goats on an island initially, and the number of goats on the island doubles every year by natural reproduction, and some goats are either added or removed each year. In part A, we're asked to find a recurrence relation for the number of goats on the island at the start of the nth year, assuming that during each year an extra 100 goats are put on the island. So, let AN represent the number of goats on the island at the start of the nth year. In the first case, we have that the number of goats double compared to the previous year. And so we have, from the doubling, 2an minus 1, since there are an minus 1 goats from the previous year. In the second case, we have an extra 100 goats are put on the island each year. So we have another 100 goats to add. And so it follows that the recurrence relation is an equals 2an minus 1 plus 100. And the initial conditions, we're told that at the beginning of the first year there are 2 goats, so that a1 is equal to 2. And we're told that no goats are removed during the second year. The number of goats only doubles. So we get that a2 is simply going to be 2 times 2, which is 4. Now, in part B, we're asked to solve this recurrence relation to find the number of goats on the island at the start of the nth year. So, notice that this is a non-homogeneous linear recurrence relation, and so the associated homogeneous linear recurrence relation is an equals 2an minus 1, and this has characteristic equation r minus 2 equals 0, with characteristic root r equals 2. And so we have that the general form for the solution to the homogeneous equation is alpha times 2 to the n. We have the non-homogeneous part of the equation. F of n is 100. This is a polynomial of degree 0. It's the same as 100 times 1 to the n. And so it follows that the form of the particular solution is going to be p0 times 1 to the n, which is the same as just p0. To find the value of p0, plug in the particular solution to the non-homogeneous recurrence relation. So we have that p0 is equal to, on the right hand side we have 2p0 plus 100. So we get that P0 is equal to negative 100. So that particular solution is negative 100. And so we have that the solution to the non-homogeneous recurrence relation in general is the sum of the solution to the homogeneous equation plus the particular solution. So this gives us alpha times 2 to the n minus 100 for some constant alpha. And using our initial condition, a1 equals 2, we have that 2 is equal to alpha times 2 minus 100. So we have that alpha is equal to 51. And therefore, it follows that the solution to the linear non-homogeneous recurrence relation is 51 times 2 to the n minus 100. And this is the number of goats on the island at the start of the nth year. In part C, we're asked to find a recurrence relation for the number of goats on the island at the start of the nth year, assuming that n goats are removed during the nth year for each n greater than or equal to 3. So again, let's have an represent the number of goats at the start of the nth year. First, we know that the number of goats double in comparison to the previous year. In the previous year, there were an minus 1 goats present, and these goats all remain on the island. So we have 2an minus 1 goats to add. We know that n goats are going to be removed during the nth year, so we take off n goats in the nth year, and then we add the cases together. We get that an is equal to 2an minus 1 minus n, as long as n is greater than or equal to 3. And we have at the beginning of the first year, we're told that there are 2 goats. So a1 is equal to 2. And we have that after 1 month, or 1 year, I mean, no goats are removed. So the number of goats is doubled to 4. So a2 is equal to 4, which is 2 times 2. So this is the recurrence relation. And so in part D, we're asked to solve this recurrence relation for the number of goats on the island at the start of the nth year. This recurrence relation is a linear non-homogeneous recurrence relation. The associated linear homogeneous recurrence relation is an equals 2an minus 1. This has characteristic equation r minus 2 equals 0 with characteristic root r equals 2. And so the general solution to the homogeneous equation is alpha times 2 to the n, where alpha is some constant. And we have that the non-homogeneous part of the relation, f of n, is negative n. And so this is the same as negative n times 1 to the n. Negative n is a polynomial of degree 1, and 1 is not a characteristic root, so it follows that the particular solution has the general form p1 times n plus p0 times 1 to the n, which is simply p1n plus p0. To find the values of the coefficients, we'll plug our particular solution back into the non-homogeneous equation. So on the left side we have p1 times n plus p0. On the right-hand side we have 2 times p1 times n minus 1 plus p0. Minus n. So we have that p1n plus p0 is equal to 2 p1 minus 1 times n, and then we have plus negative 2 p1 plus 2 p0. And so we have that 0 is equal to p1 minus 1n plus negative 2 p1 minus or plus p0. And so we have that p1 is equal to 1 and p0 is equal to 2p1, which is 2. And so we have the particular solution is n plus 2. We have that the general form for the solution to the linear non-homogeneous recurrence relation is the general solution to the linear homogeneous recurrence relation plus the particular solution. This is alpha times 2 to the n plus n plus 2. And so, using our initial conditions, in particular, we'll only use the initial condition that a2 equals 4, since this is the only condition that applies to the recurrence relation. We have that 4 is equal to alpha times 2 squared plus 2 plus 2. So we have that 4 is equal to 4 alpha plus 4, where that alpha is equal to 0. And therefore we have that the solution to the non-homogeneous linear recurrence relation is simply n plus 2 for n greater than or equal to 2. And we have that if n is 1, we still have that a1 is 2.